Hello, and welcome to today's webcast, Why Jump? An Introduction for Professors and Students. My name is Chuck London, and I will be hosting today's session. We would like to answer questions that arise during the broadcast, so please use the chat or Q&A panels to submit your questions at any time. However, we will wait until the end of the presentation to address your questions. Let's meet our presenter. Kevin Pockner is an academic ambassador with JMP. JMP is a business unit of SAS specializing in desktop software for dynamic data visualization and analysis. And we invite you to sit back and relax, and we'll go ahead and get started. Hi, Kevin.
Thanks a lot, Chuck. Let me share my screen. Okay, perfect. Well, welcome everybody to today's session. Before I jump into actually showing the software and analyzing some data, I just want to point out a bunch of resources that you can go to, especially after this session. You may have a whole bunch of questions or you want to see more. I mean, there's obviously only so much we can do within the hour. So if you go to the JMP website, there's a little tab you'll see there called Learn JMP. And inside of here is access to all these different resources to, of course, learn JMP. So if you're brand new to JMP, you can go to this Getting Started with JMP, and there'll be some quick little get up to speed, little introductory materials, little webinars that you can watch. I'm going to go to this one called Mastering JMP because this will have a much broader collection of them. So you can go to these JMP webinars, our webinar library, and you can pick, for example, to look at webinars by certain application area. So if you're teaching like a design of experiments class or you're teaching a predictive modeling class, you can also select by level. So I'm just going to click basic here just so you can see the set of basic webinars we have. And so each one of these is usually about an hour long. They're basically a recorded version of what we're doing today, right? So the one we're doing, or at least one just like it, will be on the library if you want to go see it. And go back here. We also have books with JMP, and so this is a combination of textbooks that feature JMP as well as books that are made by SAS Press. You can kind of see the mix in here. So there's a whole collection of books that we have, which are great for obviously yourself, those are new users, and I'm going to go to intermediate advanced, or to sort of, and I've done this in a class I've taught where I'll have the students get one of these as a supplemental thing. So they have a bit more of an instructional manual that they can use, so I don't have to spend all that time in class doing that. I'm going to show a few more resources. So under this Jump in Action tab, you'll see this section called Academic. So we have a little section of our website dedicated to resources for professors and students. So there's a bunch of webinars that are here. So I'm going to click on this webinar library. Some of them are similar topics and themes in that other webinar library I showed you, but these are ones that we've recorded that we think target the teaching, using JMP for teaching, right, for professors and students. So there's another collection of webinars you can see. We have this area called the Learning Library, and so I'm going to just click on one of these. So I'm going to click on graphical displays. And what we have here are these are little short videos. So each one of these might be just a couple minutes long. But if you pick a topic, then you can click on this thing called the one-page guide, and then we just have this, well, as the name implies, it's just this one-page instructional of how to run that particular analysis. And we have it from everything basic, like just doing graphs and plots and summary statistics, all the way to more advanced data science tools like neural networks and support vector machines and other predictive modeling techniques. And again, when you click on one of these, they're just these simple one-page instructional guides to show you how to run that analysis. And these are good because you can provide these to your students. So again, it takes the pressure off of you in class to have to spend all the time showing how to use JMP, because you want to focus on the concepts and the problem solving and whatever things you're teaching in statistical concepts, but you can just provide students with access to this, collection of one-page guides, so that, hey, if you want to, know how to run a linear regression, go look at that one-page guide. It just steps you right through it. So it's, I think it's much easier than you having to take on that responsibility. We also have a collection of case studies. And so these are storylines and data sets that we've put together that you can use in, for an assignment or a final project and for one of your classes. So, you can pick it by storyline or theme. You can pick it by the types of analyses that are used in the case study. And so what you'll get here is a data set and sort of a storyline, so you can provide that as an assignment or project for class. We also have course materials. So if you're just looking for slides, data sets, other things that you can use in your class, again, you can pick by a particular course topic, but we'll have all these instructional materials. Again, they could be PowerPoint slides that you can use, data sets you can use, little e-learning webinars are in here as well. So again, we're trying to assist you in using JMP in the classroom so you don't have to take on that responsibility of having all this support material. We have that here for you. Okay, so again, I just wanted to show that before I got into using JMP, so you know that that information is there. All right, so let's grab a data set here that I'm going to use. Okay, so this is a data set that I'll be in today to demonstrate some tools in JMP. So just to give you a little background of what the data set is, we have 31 athletes, and you can see right down here is that number telling me how many rows of data I have, 31. And I've got 10 variables. You see those listed right over here. And again, those are just the columns, right? And now up here on the upper left, these are saved scripts. So when I run an analysis, we save them to this file. And then whenever I want to launch them again, I just click on this and it launches it. So I already have some saved scripts, but for today, I'm actually going to show how to run those, from start, from the dialog boxes. Okay, so the focus of this analysis is oxygen uptake is the key response variable for these 31 different athletes. And then we have 7 different variables that we want to see if they can help explain or predict oxygen uptake. So we have this categorical variable gender, we have age, weight, run time, run pulse, rest pulse, and max pulse. Okay, so we have these we have these 7 other variables, and we want to see if they can help us explain oxygen uptake. Now you'll also notice that there's a column in here which is actually the picture of those people. So JMP allows you to actually put an image in the data table, and when we get to running analysis, you'll see why this is going to be handy for us to have. Okay, so I'm going to sort of walk through it if I was analyzing this data, and you'll see that JMP sort of follows that natural way of thinking of how you would look at data. Okay, so first thing is I just want to get a sense of the data I have here. Now, there's only 31 rows, so it's too hard to sort of scan it and just get a feel for it. But right up here, there's this little icon. If I click this, I get a quick little summary of the data in each of these columns. So it will tell me, for example, for oxygen uptake, what is the minimum, what is the maximum, and I get to see a little bit of a distribution. So gender, I have 2 categories, female and male, and same thing. So you can kind of see across. But what's nice about this is I can actually interact with this. So if I click on, for example, females, now all the females are highlighted. So why that's useful is because maybe I can subset that data out. Or, for example, I can say, okay, hide and exclude these. And so now, by doing that, any analysis I use going forward is going to exclude the females from it because I selected them and chose to do that. I'm going to turn that off because I don't want to do that. The other thing you can do is I can say, okay, I want all the females to be colored green. And so you see that this little green dot has appeared here. And if I say males, let's color the males red. And now you see those symbols, those green and red symbols. So now going forward, everything that I do, every kind of graph and output that you'll see, all the females will be coded green and all the males will be coded red. So it's kind of a handy little thing. Now, we can do a lot of that once we get to the graph stage. So it's not as if I had to do that. Once I get to the graph, I can add that as a categorical color variable, but I'm just doing it now so that everything I do going forward. Now, these summary little graphs are really just for a quick way to just get a sense of the data. And again, as I said, you can select data by just highlighting on these. But I'm going to show a little bit more, it's going to have a little bit more information to look at this as a summary. So under Analyze menu, the first item says Distribution. I'm going to click on that. And, like standard point-and-click software, a dialog box appears and asks us to point and click and put variables into different roles. Now, what's kind of neat with JMP is you can actually resize these things. So sometimes when you're making a list, so for example, I'm going to put all of the variables into the Y. I can't see them all. I know I can scroll, but I can actually just resize that so I can see. So it's kind of nice. Sometimes the variable names are long and you want to be able to see them all so you can move that around. You might notice there's a couple different symbols here. That gender has this little red bar chart symbol, and oxygen uptake has this little blue triangle. So that's telling JMP, and JMP's recognized that gender is a categorical variable, and the rest of them are continuous. So when I hit OK, what JMP is going to do is it's going to say, OK, for continuous variables like oxygen uptake, I'm going to make a histogram with a box plot and some summary statistics. And so you see this on the top of the output. If it's a categorical variable like gender, it's going to make a bar chart and give some counts and frequencies and percentages in this little table. Okay? Now, just like I showed you on the data table, I can interact with this, right? So I can go around. But what's nice is when I click on something, let's say I click on females, I can see where does that data land across all variables. So for example, just kind of peek up here at oxygen uptake. As I go between females and male, it kind of looks like there's a little bit of shift there, right? For females, the oxygen uptake values tend to be higher, and for males, they tend to be a little bit lower, right? So I'm just seeing that from there. And again, I can highlight, I could actually do it the other way. Those are the large ones. These are the small ones, and you can kind of see, right, most of the small ones are male, and the majority of the large ones are female. So this allows you to kind of interact and play with it. Now, right from here, if you were doing something more advanced, like let's say, for example, you're going to do, let's say you're doing a t-test. Well, everywhere in JMP that you have output, you'll see these little red triangles. And when you click on the red triangle, that's where you'll see options related to that. So if I click on the red triangle for oxygen uptake, here's a list of all things that I might want to do next with a continuous variable. So for example, I can put a normal distribution plot over that. And so that gets added along with over here on the far right, you'll see statistics, measuring the goodness of fit of putting a normal distribution on that, right? Take that away. Now you can also move around these axes, so I can kind of drag them like this. I can actually rescale them. So you see I'm rescaling it, right? But if I click on this red triangle for this continuous variable, there's where I'll find the option to sort of test a hypothesis about the mean. So I'm going to click on Test Mean. A little dialog box appears, and let's just say for illustration, I'm going to test it if the mean is 48. Then when I hit OK, then the standard sort of t-test output gets added to this distribution display. Now, again, every time you do something, you'll see little red triangles, and that's where you can do some options. So here is where I could choose to select the summary statistics I want to display or what confidence level I want. Here's the red triangle for the results of the hypothesis test on the mean. And this is cute. We have this in a couple of different places in JMP. I'm going to click on this p-value animation, and this little tool will pop up. So if I'm explaining the concept of a p-value to my students, I can sit here and drag around the value of the mean I'm testing under the null hypothesis, and then show how the p-value would change relative to the particular sample mean I got. And so that's kind of neat. And there's also one up here for power. Okay, so if I'm trying to explain the concept of power to students, and I can move around the value I'm testing under the null hypothesis, and same thing, I can move around what the true mean is, right? So this allows you to kind of explain that concept of power to students. Now, you'll also notice these little gray triangles too, which that just is what allows me to sort of close up some output if I don't want to see it, right? Just to make the screen a little cleaner. But if I want to see it all, I can have it displayed. Now, if I go under the red triangle for a categorical variable like gender, well, that's a categorical variable, so there's going to be different options. Okay, so here is where, for example, would be if I wanted to test a hypothesis about a proportion, and then so I could launch that, or it's just other displays. Same thing, choosing a confidence level. Okay, now if I want to save this output that I have here to the data table, I'm going to click on this top red triangle. I'll save script to data table, and I would give it a name, and I click OK, and you'll see it just got added to this upper box here. So if I close it, well, it's still saved to my data table. So whenever I want to see it again, I just click on the green triangle, and it launches it, and I get back to that view. So this is just where as you run analyses, you save them over here, and then whenever you want to see them, you just launch them again. And it runs it as a script, so this way you can change the data. If you want to say, okay, now I want to see the results of that analysis on this updated data I did. Now you can have it so it's just going to run. You'll get fresh output because you've changed the data. Okay, so let's kind of dig in further. Well, again, that was just to get a handle on the variables we have here, looking for outliers, just getting some summary statistics. Let's now kind of dig into the main point, which is seeing if we can explain oxygen uptake by these other variables. Okay. So I'm going to start off with just graphing first. So the way JMP makes graphs is through this tool called the Graph Builder. So you don't have to think ahead of time, well, what graph do I want? What variable do I want here? And what symbol do I want here, et cetera. Instead, you launch this thing called the Graph Builder. And basically, you're looking at this blank canvas, waiting for you to build your graph. Okay? So let's say I want to put oxygen uptake on the y-axis. So I can pick it up and grab it, or I can just have it selected and then come over here and click on that region, and it's going to drop it there. Now, I only have one variable, oxygen uptake, so it's going to just display it on the y-axis like this as a dot plot. Now, if I wanted to see, for example, a histogram, I could say, well, show it to me as a histogram, and I can click on that. If I want to see a box plot, I can click on the box plot. Or if I want to see a box plot and the dots, I can do that. Or here's something called the violin plot, and the dots are kind of just showing where the density is. So if I want to see the mean and a confidence interval, I can add that. If I want to put some summary statistics up there, here's a prediction interval, here's means and standard deviations. So every time I select something up here in the palette, the options over here on the left will change relative to what I might want to see. So again, I'm just, there's like maybe a display I want. The dots, you see them colored by the gender, and then as well as a box plot and a confidence interval display. Okay. Now, actually, what I'm going to do is I'm going to go back here, and I'm going to turn off how we made the colors, red and green for the two genders, just to shut that off. And I'll show you that you can do it from here as well. So I've got oxygen uptake on the y-axis, and if I grab one of the other continuous variables, so I'm going to grab age, and I put it down here on the x-axis, well, JMP's going to say, oh, well, then you must want a scatter plot. I got a continuous y and a continuous x, obviously. So if I want to see the regression line on that, then I'm going to add that. And again, so I got confidence interval, I can put the prediction interval, I can put the R squared, I can put the equation, the results of the F-test. So you can see all that is appearing up here if I want to turn any of that on. So I'll leave it on as we kind of look at the data. Now, remember I mentioned that we have the image of a little picture of each of these athletes in the worksheet. Well, why that's neat is I have this set up so that's going to be the label. And so when I float over a point, that picture comes up along with the information about those two variables. So now I can float around and see that image, whatever that happens to be. And I've seen people do some really neat things with this. I've seen some, a geneticist had sort of actual images, microscopic images of these viruses that they had, so that as they're looking at these graphs and data, they can float over and see a picture of it. I've seen this manufacturing company that they make sort of the ceramic material, and there's all these sort of defects that can occur on the material. So they measure all these properties, but they also take a picture of it. So this way it's kind of neat because you can carry that information along. So when you float over a point in a graph, you can actually see the image that corresponds to that. So I've got just one variable, age, on the x-axis. Now gender was that categorical variable. So I can put this variable in different roles. So I'm going to pick it up. And so if I put it up here, it's going to say, okay, I'll panel it. I'll have oxygen uptake versus age, but one for females and one for males. And you can see the two panels and all the summary statistics, the equation, R squared, are displayed up there. I could put it over here, which is just going to panel it that way. I can put it overlay here, which is going to put the two equations on the same graph. I could put it here for color, which is just going to use gender as a color. It's going to fit just one equation. So if I let it go here, then that's what I have. Okay. And we kind of had done that coloring at the beginning, but I'm just showing you now that you can save that to later and do it inside here. And again, there's different ways, there's different roles. And if I don't like it there, just grab it and just remove it, right? Put it where I want. I think what I'll do is I'm actually going to put it on top of each other like that. Now, if you want to play around with this graph in terms of like the axes or symbols or tick marks, you can just double click on any of the axes and all this information pops up here. So for example, I can switch it to say, show me this graph, but have that axis on the log scale. Or change the tick marks or the colors or the fonts or put reference lines, okay? All that kind of stuff is available. But I can still kind of interact with this if I want to play around by just clicking and dragging. Okay, so let's imagine I want to see this same graph, but now I want to see it for, instead of age on the x-axis, I want to go to the next continuous variable, say weight. Now, typically in software, then you'd go and make another graph, right? And then okay, now I got to make one for runtime, and then make one for run pulse, and so on and so on. Well, with JMP, you don't have to do that. What I'm going to do is I'm just going to tell JMP that I want to swap out the age variable that's on the x-axis. I want to swap it out with all these continuous variables, and then by doing that, you'll see over here on the upper left of my display, I have this thing called the column switcher. And now what I'm allowed to do is I can just look at that same graph and just swap out what's on the x-axis, right? So I can use this as a way to get that same view, but just swapping what I'm looking at. So, for example, there's a pretty strong relationship that we're seeing right there. When, again, you can look at the statistics, the equation, R squared, and all that if you want, or you can just sort of see how the visual display is showing it. Okay? Now, if I wanted to create separate graphs for each one, I can certainly do that. I just chose to show you how I can just kind of swap out the variable from the one graph. Okay. The other thing you can do, and not only at the graph level, I can do this when I'm looking at a more formal statistical analysis, is I can bring up this thing called the data filter. And what the data filter allows me to do is I'm going to bring, I'm going to switch this to weight. Actually, let me show the one with the strong relationship runtime there. What I'm going to do is I'm going to click on age, for example. And now, you know what I'll do is, even though this isn't necessarily showing the power of it, I added gender. So right now I have this data filter. So this section right here is a data filter. This section right here is my column switcher. This allows me to filter the data. So I said, hey, I only want to see the females on this graph, so I can click on this. Or I only want to see the males on this graph, I could click on this. I could also come over here and I can start dragging a continuous variable. Now notice as I'm doing this, everything is changing on the graph. So I could say, for example, hey, you know what? I only want to see the data where the athlete's age is under 50. and now this whole display is only showing me that data. Or maybe I only want to see the data where the age is over 45, and so it's filtering that data according to this. Or over 45 and you're a male. So I can set this local data filter and column switcher like I'm doing here, which allows me to just take one display, one graphical display, and start looking at every possible kind of combination of all sorts of other variables I want. And I can just, you can see that's happening live as I'm moving around and selecting. And that's one of the things that I think makes JMP stand out from other statistical software is you don't have to run another graph and then another graph and then another graph. For every kind of combination of something you think of, you can just do it all from one output. And this is true not just in graphs. You'll see this is true even when I get to, building a statistical model. I can do all that filtering and column switching at that point. Okay, so I'm going to close it up here. Okay, so that what I showed you was this graph builder tool, and it's how you build graphs. You don't have to think ahead of time of what exactly I want. You sort of build it to the point of that's what I want. I think it's a very innovative way to make graphs, because you don't have to kind of plan the whole thing up front. You kind of build it as you find the features in the data and explore. So let's get back, continue on our exploration of finding variables that are related to oxygen uptake. I'm going to go down to the second tool in the Analyze menu called Fit Y by X. Okay, now this is where you would do a simple regression, a simple logistic regression, a contingency table, or a one-way ANOVA. So I'm going to put oxygen uptake as the Y, it's my response. I'm going to put all these variables as X. Again, like I said, you can make this bigger if you want to see them all there. Now JMP's going to know that if you give it a continuous Y and a categorical X, well, JMP's going to do a one-way ANOVA, right? Because that's what it is. If you have a continuous Y and a continuous X, well, then JMP's going to do a simple linear regression. If you had a categorical Y and a categorical X, well, then JMP's going to do a chi-square contingency table. If you have a categorical X and a continuous Y, well, then JMP's going to do a logistic regression. So you don't have to pick that ahead of time. You just know I've got an outcome, I've got a response called Y, and I've got some explanatory or candidate explanatory predictive variables, factors, we'll call them X. So it's not going to run a multiple linear regression here. That's a different tool, which I'll show you right after this. This is just, I want to do one at a time, Y by X. So I'm going to hit OK. And the first thing JMP will do is it's going to show me graphs for every one of those that I just asked for. And then under the red triangle is going to be the options to see more. So for this first one, gender, well, that's a categorical explanatory variable. So all the options under this red triangle are going to be those related to a categorical X. So for example, if I wanted to see the output corresponding to ANOVA, I would click on that. And then now displayed below the graph is all that standard output that you would see. I'm going to make this, hold on. If you see now all the standard output that would correspond to one-way ANOVA. And again, you can kind of collapse these, which is nice, so that if you're teaching and you don't want students to get distracted by all the output, you can just say, all right, let's just focus on the ANOVA table, and you can close the other things up if you want. If I grab a continuous categorical variable output like here, now you'll see this list is different. Well, these are the things that would correspond to doing a simple linear regression. So now what I'm actually going to do is I'm going to click an option so I do them all at the same time. So I'm going to hit this fit line, and it's going to do a simple linear regression for all these remaining variables. Okay, so I just added that. And so now that you see below each one of these is all the output that would correspond to that first step in doing a simple linear regression. Right, ANOVA table, the hypothesis test, the R-squared, the equation. Remember, I can still kind of interact with these. I can still play with data. So see, as I'm highlighting data in one graph, it's getting highlighted across all graphs. I still have that ability to see that little picture if I float over. Okay. Now, there's another red triangle under this regression output. So if I click on that, now I'm going to see more options. So for example, standard thing we teach when we're teaching regression is to look at the residuals. So I can say plot residuals. And then now what happens is, and I just did it for one of them, that's why you'll see it just in this one for oxygen uptake by age. So if I scroll down, you'll see I've got that standard linear regression output, and then I've added the residual plots below it. Okay, and again, I can close those up if the purpose is to keep the area clean. And again, you'll see the standard things you would do in a simple linear regression, right? You might want to save the fitted values and the residuals, and you can put that information there. I'm going to do a little confidence interval there. I can shade that region. I can do a prediction interval. I can add that. Okay? Or again, I can go in there and just turn them off, turn them on and off. Okay? Now, remember when I was showing you in the, I'm going to do this. Remember when I was showing you in the graph builder how I can pull up data filters? I can do the same thing here. So I'm going to pull up this data filter. And just to illustrate, I'm going to put gender and age, similar to what I was doing in the graph builder. So all of this output, the graphs, if I have the residual, I'll put the residual plots for this one up here. Okay, so all of this output, I have it just selected for this one, oxygen uptake by weight. But again, you see the ANOVA table, all the standard diagnostic plots right there. And over here, I've got my data filter set up. So if I say, okay, I want to see how all this output looks like only for females, and I click on this, everything changes. All of this regression output across every other variable, the residual graphs, everything I'm seeing here, I'm only seeing the data right now for the females. Okay, same thing, I can switch to show males. Again, you see how everything's changing, all the output, all the numerical output. Now, the same thing is true if I move a continuous variable around. So I'm going to grab age, and as I'm sliding this, I'm starting to eliminate athletes who are not under that age, and you'll see everything's changing. The test statistic, the ANOVA table, the residual graphs, the equation, everything is changing as I'm sliding this over. So why I think this is great for teaching, I think JMP stands out for statistical software for teaching, is I always found when I taught, and also when I was learning, that the best way to learn something is to watch how something changes or doesn't change when you change something else, right? So if you're trying to illustrate a concept like an interaction or the importance of a variable, you start clicking back and forth and going, okay, notice what's changing and what's not changing when I switch between something else. And so I think as aside from a great way to analyze data, I think it's an excellent way to teach, because you don't have to go, oh, now let's make another piece of output and compare across output. You can kind of watch it dynamically change as you're doing something. And so, again, those classic examples, like where you have an interaction, you can kind of watch that. Oh, look at the equation's shifting. See how it's moving? That's the interaction. So you kind of watch it dynamically happen instead of just running another piece of output, like if you're doing it in R or something, and then running another piece of output and comparing back and forth. You can actually watch it dynamically change. So I think that's just a real cool way that JMP approaches it. Now, again, this is just looking at the output one at a time, one variable at a time. Okay, but we kind of see the same things we saw when we were looking at the graphs, that runtime. This one looks like it has probably the most significant relationship here. Now, if I wanted to save this, I could go save to data table, and I'll have that output or that script saved, which I do right here. But move this over just so you can see. So I've kind of saved some of these already, and I can just kind of launch it again if I want to see it. All right. So now let's get to building a model that's going to be a multivariate model. In fact, that's going to have all of these ones in there, or at least maybe it's going to have all of them in there. We'll see which ones are most important instead of looking at them one at a time. So that is done under our Fit Model platform. I'm going to launch Fit Model. Okay. So this is going to do a multiple regression. So I'm going to put oxygen uptake as the Y. And I'm going to put all of these variables. And actually, you know what I'm going to do? I'm actually going to put all the variables as well as the interactions. You can see that long list there. We got quite a bit. So I'm just setting this up to say, okay, test not only for any individual main effect, but have all the interactions that are in there. Now, if I hit the run button right there, I'll just do that and then stop it. It's going to run a full multiple regression with all of those variables in there. Okay, so here is a piece of that output. And what's nice is it has this this table that I'm highlighting right here called the effect summary table, and it's showing a list of p-values corresponding to that term, the classic, if that term put in the model last. Now, what I can do right from here is I can actually start reducing the model if I wanted to. So, for example, I'm going to start with the interactions. That's the proper way to reduce a model. So notice this gender times runtime, that has the highest p-value for the two-way interaction. So I can just say remove, and I remove. So I'm reducing the model right now by just doing it kind of right from here. So I don't have to go back and say, okay, rerun the model, but only use these variables. You don't have to do that. In fact, I can click add, and I can actually add them back. So it allows me just from this one output to add and remove variables until I get to the final model I want, as opposed to having to go back to the model platform, run it again, run it again, run it again. I can do that directly right from here. Okay. Now, what instead I'm going to do, close this. I'm going to bring that fit model platform back up. Okay. And what I'm going to do is I'm going to launch instead stepwise regression. So instead of me manually reducing the model, I'm going to run JMP's stepwise routine. So basically, it's sitting here waiting for me to either go step by step if I want to go forward selection or backward selection. So what I'm going to do is I'm just going to set some criteria here. I'm going to be a little stricter here. Okay. So I'm going to run. Let's go back to. So I'm going to click this button, go, and then JMP is just going to run through the forward stepwise routine, including only the variables that meet some criteria, which I gave it, and those are all selected. So it's saying, okay, you should build a model with these variables. So I'm going to run the model, and now the model is built with only those variables that are selected from the stepwise routine. I'm just going to close that. Okay. So instead of manually starting off with the full model and me manually reducing it or building the model back up, that back and forth process, I just had launched JMP stepwise routine to do it automatically for me. And again, I can add and remove terms right from here as well if I want. Okay. So let's see, a bunch of plots that come up with here is, the standard NOVA tables, the hypothesis test, right? If I want to see the actual equation, I can say, show me the equation, and then here's the fitted model right here. But what I think is more useful when trying to describe what the model is to bring up this thing called the profiler. And so let me move this up higher up the screen here. Okay. So this profiler is now, and also I can resize things in JMP here, so it's very easy for me to make that a little bigger. So now with this profiler, I can actually interact with each of these variables, and I can see how the prediction changes, and there's a predicted value and a confidence interval, as I move around across these candidate explanatory variables. Okay, and so for example, do I have? I'm trying to see, oh, okay. So just looking here, gender, weight, gender, age. Okay, those are involved in interaction. So this again is that concept where if I was teaching students the idea of an interaction, notice these first two, age and weight. As I go between the two genders, the curve is changing a little bit. The other three, it's just shifting up and down. So if I was teaching students that concept of an interaction, I don't have to go fit a different model and try to compare the graphs. I can just work from this one graph and show, hey, see what's going on there? See how age has an interaction, right? Now, I can also, if I want to do this as a surface, right? So now I have a surface plot of this. Actually, I always like plotting the, let's see, let's put on, I can put on contours. I'll put that I'll put that on the bottom if I want. And I can start moving around other variables, not just the ones that are in the contours, or select ones, right? I could be like, okay, show me runtime and run pulse. Here it is. And then I can pick different genders if I want to see that, or different ages, right? So it allows you to kind of play around, easily play around with this. And just putting on some little grids there. And just I can kind of move around, interact, and play with that. I can also, if I want to see this as a contour plot, I can do that as well. And here down here is I'll have my contour plot, and I can move around sort of some region if I want to demonstrate how I'm in some region. Okay. So every time we run an analysis in JMP, we always have these graphical displays that are interactive and can let you play with. And just like I talked about with that concept of a data filter, I can do that even from here. So I can bring up this data filter. I'm going to click on, let's say, gender and age. I keep on doing that. And it's the same thing. I can say, well, show me all this output for only the athletes under 50. And as soon as I click on this, everything changes. Everything. The profiler graphs, the contour plot, the surface plots, all this output is changing because I filtered the data by that. Or same thing. Show me just females under 50, and again, all of this output is changing as soon as I filtered the data by that. I'm just going to remove that local data filter from there. I'm going to click on the red triangle just to show you the other things that are under there, right? The classic, residual plots if I want to see that. If I want to start doing more detailed hypothesis testing, like if I'm doing multiple comparisons, like, some of that standard stuff that you would see if you're dealing with, multi-factor ANOVA or regressions. If I want to save any of this information into the data table because I might want to create some other plots, do some other analyses off of that, I can save that information, and you have a good all right. Now, I think what I want to do next here is, let's look at the time here. Okay, I do want to save some time for questions. So there's one more thing I can squeeze in here. No, that might require me to get a different data set. Let's just stick with this one data set. So why don't we actually go ahead and open it up to some questions. So Chuck, I don't know if you have questions either coming in through the notes section of WebEx or not.
That's right. So we do have a couple questions. I'll get to those in just a second. If while Kevin's answering questions up to this point, you have any questions about today's presentation or about the software in general, please do write them in the chat window or the Q&A window, and we'll try to get to those. So great job today, Kevin. The first question that came across was about saving the work, saving your work that you do.
Yep.
Within JMP, and how easy is that, and how would you do it?
Okay. So anytime you run something, and I'll just do a simple analysis here, oxygen uptake, and I'll put age here. So I'm just getting a simple linear regression, and again, you might do all sorts of things to it. Here's the equation. Maybe I want to save the plot the residuals. And so I have this display here from running a simple linear regression, And under the top red triangle, there's always this option that says Save Script. There's different places you can save it. Like we actually have a journal, so you can sort of save things to that journal. And also, if you want to just sort of copy paste it, you can grab little sections of output if you want. You can see here I'm just clicking on different pieces, and then you can kind of save that out to a file if you want. In fact, let me, I'll show you that in a second. But the standard thing you do is you save the script to the data table, and when you do this, and I'm going to hit OK. Now watch over here on the upper left, this section right here. As soon as I hit OK, then that just got added. I can close it, and whenever I want to see it again, I can launch it. Okay. But a lot of times that's not the only way you want to save output. So under the File menu, I have the ability to, I'm going to say Export, and then I can choose how I want to export this information. Let's say I'm going to put it in a PowerPoint slide or something like that. So, or if I just want to save it as an image, I can actually save it as HTML. And so then it actually will create a website and that a little HTML document, so that now someone else outside of JMP can view the output. And in fact, in many cases, you can still interact with it. So that's nice because a lot of times you're sharing files or you're sharing output with people that don't have JMP, right? Maybe it's a colleague or something. Well, you can save it out to this HTML file, and then this way they can view it without even having to have JMP. But I'm going to select PowerPoint. I hit PowerPoint next. What it's going to do is it's going to, hold on here, let me put a place to save it. Okay. So it just basically launched PowerPoint automatically, and each of those pieces of output, it just dropped into a different different slide in PowerPoint. Okay. But once I'm in there, I can start doing things, moving around, deleting stuff if I don't want. So that was just a quick way just to say, hey, throw all that output from this set of results here, this little report on a simple linear regression, and just take each one of those pieces, the tables and the graphs, and just chuck them over to PowerPoint, and then now I have them in that format. So that's typically what you're doing, is you're either just saving the script to the data table, like I did here by putting it in this area, or you export certain pieces, like I want this as a picture, I want to save this into PowerPoint, or which I think is really cool is you can send it out to an HTML file. And actually, maybe I should just do that instead of just talking about it. So export HTML, give it a place to save it. Okay, and then now here's an HTML page it's created based that all that output. Okay. And what's nice about this is this can be set up so I can still interact with it. So the user can be out here switching between, say, male and female and watching output change. Not every piece of JMP analysis does that, but certain select ones do that I can still even interact with outside of it. So now what's nice is I can save this HTML file and share this with somebody or put it up on a network at school, and others can look at it without having to open up JMP. Okay.
Great, thanks, Kevin. We've got a couple more questions. So we've got an attendee asking, how would you describe the learning curve of JMP compared to other industry modeling software for statistics?
Yeah. Okay. No problem. And having been a statistician for 25 odd years, I've had the opportunity to use many of those those software packages like Minitab and SPSS, and I would say that, like any point and click software, whether it's statistical or not, right? It's just about learning where something is, right? This is this menu. This is where I click. But I think what's something that makes JMP stand out is that, let's say that concept I was showing you about building a graph. Well, you don't have to know everything at the beginning. You start interacting with to create it. So as a user, you're like, okay, I want to make a graph. Let's see. Maybe I want oxygen uptake on the Y. No, maybe I want it on the X. Oh, maybe I want a histogram. No, that's not what I want. Maybe I want a box plot. Maybe I want to see the dots. No, wait, change my mind. Now I want it on Y. Let me put weight over here on X. And oh yeah, gender. That's what I want. I want gender as a color. And maybe this other variable, I want to panel it. No, I want to wrap it this way. Okay, I'll put it there. Now let me add the regression line. So what's nice about it is unlike other software where like if you don't specify all the stuff up front correctly, it doesn't make the thing you want, right? You're like, I'm getting an error message, or why is it not making that graph? But with JMP, you're sort of interacting and doing it to build the graph. And I think by kind of definition, that just makes it easier because you don't have to know as much. But to me, it's like any point and click software. You just learn where the names of things are. You just drag variables into different places, right? Point and click, really easy. And then the person asking the question, if you were on at the very beginning, I think one thing that separates us from other stat software companies, the amount of resources we have to support users, right? We have hundreds of hours of videos, hundreds of pages of instructional one-page guides, short videos, books. I mean, there's dozens of books we've created, manuals that I think the support that we provide is what holistically makes JMP a pretty easy software to use.
Great, thanks, Kevin. So as you know, JMP is up to version 15 right now. Were you using what version of the software were you using?
I was using 15 Pro.
Okay. And did you show any Pro capabilities, or were they all?
I did not. Everything that I showed was just in JMP. And though the nice thing about our academic license is if your school gets the academic license, or if you already have it, you actually have both JMP and JMP Pro. And so the things that JMP Pro is going to have that JMP doesn't have is more of these sort of modern data science tools, right? Like support vector machines and neural networks. It's going to have a lot more of these advanced techniques than JMP. But everything I did today, that's standard JMP stuff. That's you'd be able to do that in JMP. But again, the academic license, you have JMP Pro with it, so it's not really a worry.
Great, thanks, Kevin. So a couple of people did join late. I don't know if you just want to, and we don't have to go back through it, but if you wanted to go to the jmp.com/academic page to just highlight again the resources, because like as you said, I think that's a pretty big differentiator between JMP and other tools.
Yeah. Okay. So I'm going to the website here, jmp.com. And hold on, a little slow internet here in the office. Oh, there we go. And so we have this academic section of the website that has a collection of all sorts of resources we have webinars, like basically you're listening to a webinar right now, so you know about signing up for a live academic webinar, but we have a whole webinar library, which has a whole collection of a few dozen recorded webinars. We have our learning library, which has these quick little one-page guides, little how-to videos, we have case studies, course materials, and then books with JMP. So if you go to this section of jmp.com, which is our academic section, you'll find a whole bunch of things to get up and running. And it's not too hard to play a couple videos, or in fact, I know professors that what they'll do each week of their class, in Canvas or one of the online course tools that exist now, they'll put up the relevant videos and one-page guides and other things that we have to that particular week's lectures, right? So this way, this professor is telling me, he's like, I don't want to spend time in my class answering all their questions. So I give them, hey, watch this video before you come to class, go through the steps to run this output, and then in this week's class, we're going to talk about the output. And so we have a lot of these resources that you can just point your student to, as a side for you to learn, because, as many of you probably know, that the secret to being a professor is to, convince your students that you've known something all your life that you just learned a few weeks ago. So it's very easy to stay a few steps ahead of the students with all our resources.
Great. Thanks again, Kevin. And we've got a couple of more minutes. If there are any other questions, we've answered all the questions that have come in the chat so far, but if you wanted to send another question or two, we should be able to get to it. In the meantime, I wanted to mention that if you think of questions afterwards, we do have an academic mailbox and I personally help monitor the mailbox. It is academic@jmp.com. You can send an email there, and I or one of my coworkers will be sure to find the email and route it to the right person for answering. Also, as far as the academic license that Kevin has referenced, again, we do have different versions, but the JMP Academic Suite, as he mentioned, comes with JMP and JMP Pro, and the ability to load the software onto classroom or lab computers, as well as personal computers for academic use. So students can access the software outside of the classroom and can use JMP for homework purposes. Otherwise, that is all of the questions that have come through. Again, please don't hesitate to reach out via email if something comes up, or if you have any questions about licensing JMP academically, or if you have questions about using JMP, we're happy to help. Thanks again, Kevin, for a great webcast. We appreciate it.
Thanks very much, Chuck, for organizing.
Anytime.
Okay.
And thank you all for joining.
Bye. Thank you.